I'm Dr. Binu. In Artificial Intelligence and Machine Learning Fundamental subject, the fifth topic in the third unit is Machine Learning Model Evaluation. Model evaluation is the process that uses some matrices which is used to help us to analyze the model's performance. The model development is a multi-step process. Here we have to uh, check how well the model generalizes the future predictions. Evaluating a model plays a vital role so that we can judge the performance of our model. The evaluation helps to analyze the model's key weakness also. There are many evaluation matrices are there. Some of the matrices are accuracy, precision, recall, F1 score, area under curve, confusion matrix, and mean square error. Cross validation is the one of the technique that is used to follow during the training phase, and it is a model evaluation technique. What is meant by cross validation and the holdout? Cross validation is a method in which we do not use the whole data set for training. In this technique, some part of the data set is reserved for testing the model. There are many types of cross validation, out of which k-fold cross validation is mostly used technique. In k-fold cross validation, the original data set is divided into k subsets. The subsets are known as folds. This is repeated k times where one fold is used for testing purpose. The remaining k minus 1 folds are used for training the model. So each data point acts as a test subject for the model as well as they act as the training subject. It is seen that this technique generalizes the model well and reduces the error rate. Then we will see what is meant by holdout. Holdout is the approach which is used in neural network as well as in many classifiers. In this technique, the dataset is divided into trained and tested dataset. Here the dataset is divided into normally in ratios like 70-30 or 80-20 model. Normally, a large percentage of data is used for training the model. Small portion of data set is used for testing the model. Some of the evaluation matrices for classification the task. First one, accuracy. Accuracy is defined as the ratio of the number of correct predictions to the total number of predictions. This is the most fundamental metrics used to evaluate the model. The formula for the accuracy is true positive plus true negative divided by the summation of true positive plus true negative plus false positive plus false negative. The second matrix is precision and recall. Precision is the ratio of true positives to the summation of true positives and false positives, which is used to analyze the positive predictions. The drawback of precision is it does not consider the true negatives and the false negatives. What is meant by recall? It is a ratio of true positives to the summation of true positives and false negatives. This is basically analyzes the number of correct positive samples. The next matrix is F1 score. F1 score is the harmonic mean of precision and recall. It is seen that during the precision recall trade-off, if we increase the precision, recall decreases as well as the vice versa. The goal of the F1 score is to combine precision and recall. What is meant by confusion matrix? Confusion matrix is an n-cross n matrix where n is the number of target classes. It represents the number of actual outputs and the predicted output. Some of the terminologies used in confusion matrix are true positive. It is also represented as TP. It is the output in which actual and predicted values are yes. True negative. It is represented as Tn. It is the output in which the actual and predicted values are no. False positive. It is also represented as Fp. The output which the actual value is no, but the predicted value is yes. False negatives. It is represented as Fn. It is the output in which the actual value is yes, but the predicted value is no. The next matrix is AUC ROC curve. AUC is nothing but area under curve. ROC is nothing but receiver operating characteristics. AUC is an evaluation matrix that is used to analyze the classification model at different threshold values. ROC is a probabilistic curve used to highlight the model's performance. The ROC curve has two parameters. The first one is TPR, it is true positive rate. It normally follows the formula of recall. The second one is FPR, it stands false positive rate. It is defined as the ratio of false positives to the summation of false positives and true negatives. Thank you.